In this very lesson, we shall be looking at subsets of a set. Subset of a set. So let's consider set M and then set N. So we have a set M is said to be a subset of N if all the elements in the set M can be found in set N. So the condition is if all the elements in set M can be found in what? Set N. Then we can say that set M is a subset of N. So let's consider these two sets that we are talking about. So we have set M. Let's say that it contains the element 1, 2, and then 3. And then we have another set, which set N, which contains the element 1, 2, 3, 4, 5, and then 6. So we are saying that set M is said to be a subset of this set N if all the elements in set M can be found in set N. So we are going to take the elements one after the other and then cross-check to see if all the elements in set N can be found in set N. You realize that we have 1 is also here, we have 2 is also here, we have 3 is also here. So it means that all the elements in set M can be found in set N. Therefore, set M becomes what? A subset of this particular set N. So set M becomes what we call the superset. And then set M becomes what? The subset. Because all the elements in set M can be found in set N. So therefore, we can say that set M is a subset of set N. That is the smaller set of the bigger set. Similarly, if you have, let's say, set A, which contains the elements A, B, C, D, E, and then F. And then we have another set, let's say set B, which contains the elements B, D, and then C. And I want to check the relationship between set A and then set B. Now realize that all the elements in B can be found in set A because we have B here, B is also here, we have D here, D is also here, we have C, C is also here. So realize that all the elements in set B can be found in set A. Therefore, B becomes a subset of this particular set A. So we can say that set B is what? A subset of set. So we can say that set B is a subset of A because all the elements in set B can be found in set A. So set A becomes the superset and then set B becomes what? The subset, smaller set of the bigger set. Now let's come to real life. Now we know that in the nuclear family we have what? The father, the mother, and then children. So let N represent the set of the nuclear family. So we have the father, the mother, and then what? The children. Now, if we have a set which contains, let's say, the mother only, now we can say that the mother is a subset of the nuclear family because the mother is contained in the nuclear family and it is here. Also, if we have another set which contains the father only, then we can say that this set which contains the father is a subset of the nuclear family because the father is contained in the nuclear family, which is what? The bigger set. More also, if you have another set which contains, let's say, the mother and then the father, then we can say that this set is also a subset of the nuclear family, because the father and then the mother can be obtained in the nuclear family. So that is all about subset, a smaller set of a bigger set, if and only if all the elements in the smaller set can be found in the bigger set, which is called the superset. So with the first example, we said that M is a subset of what? N. So we have M now this can be written as M is a subset of N, or M is a subset of N. So this symbol means what? Subset. This symbol means sub what? Set. So we also said that B is a subset of A. We can write it symbolically as B is a subset of A. We also said that the mother is a subset of the nuclear family, right? So we can say, let's call this set, let's say set Y. So we can say that Y is a subset of N. So this symbol means what? Subset. I believe you are getting the concept. Now let's look at proper set and then improper set. So we are looking at proper and then improper subsets. So let's consider, let's say set A. Let's consider set A, which contains the element, let's say 1, 2, 3, 4, 5, 6, and then 7. And then we have another set B, which contains the element, let's say 2, 4, and then 6. And then let's consider another set C, which contains the elements 1, 2. Now, with set B, I believe you agree with me that set B is a subset of A. Why? Because all the elements in set B can be found in set A. All the elements in set B can be found in what? Set A. Therefore, set B becomes what? A subset of set A. Set C, you can also observe that all the elements in set C can be found in set A. Therefore, we can say that set C is a subset of set A, or set A is a subset of set B, because all the elements can be found here and all the elements in this set can also be found here. So they are subsets of each other. We want to determine if these two sets are proper subsets or improper subsets of set A. So we are going to start with B. We want to determine if set B is a proper subset or improper subset of A. Good. Now with proper subsets, if the number of elements in the subset is not equal to the number of elements in the superset, then we can say that that subset is a proper subset. Now, what this means is that Now looking at set B, we realize that the number of elements in set B, so number of elements in set B is what? 1, 2, 3, right? So we have 3. And then the number of elements in set A, which is what? The superset, is what? 1, 2, 3, 4, 5, 6, 7. So what we are saying is that if the number of elements in the subset is not equal to the number of elements in the superset, then we can say that that subset is a proper subset. So we realize that the number of elements in B is 3, and then the number of elements in the superset A is 7. And we realize that set B, the number of elements in set B is not equal to the number of elements in set A. Therefore, set B becomes what? A proper subset. I guess you are following. Let me say it again. With proper subsets, if the number of elements in the subset is not equal to the number of elements in the superset, then we can say that that subset is a proper subset. So realize that the number of elements in the subset B is 3, and then the number of elements in the superset, which is A, is 7. And realize that the number of elements here, the subset B, is not equal to the number of elements in the superset A. Therefore, subset B becomes what? A proper subset. So that's what I've written here. Since the number of elements in B, which is 3, is not equal to the number of elements in set A, then we can say that set B is what? A proper subset. Good. That is what? Proper subset. Now let's move on to improper subset. So when we talk about improper subset, then we are saying that the number of elements in the subset must be equal to the number of elements in the superset. So it means that we are going to check the number of elements in the subset. So with C, we are going to check what? The number of elements in C. How many elements do we have here? We have 7 elements. And then with number of elements in set A, we have how many elements? We have 7. Therefore, since the number of elements in the subset C is equal to the number of elements in the superset A, we can say that set C is an improper subset. So we can say that since so that is that for proper subset and then improper subset. I guess you are following. Let's take another example on the proper and then improper subset. So let's consider set X, and then we have another set Y, which contains the element A and then what? B. Now I want to check whether Y is a proper subset or an improper subset. But first of all, you agree with me that Y is a subset of X, because you know that all the elements in Y can be found in X. So you can say that Y is a subset of what? X. Y is a subset of X, because all the elements in Y can be found in X. We can write this symbolically as Y is a subset of X. We want to check if Y is a proper subset or an improper subset of X. So with the improper subset, we said that the number of elements in the subset must not be equal to the number of elements in the superset. So you realize that the number of elements in Y, we have how many elements? 1, 2. So we have 2. And then we have number of elements in X. We have what? 1, 2, 3, 4. We have 4. So you can see that the number of elements in the subset Y is not equal to the number of elements in the superset 4. Therefore, we can say that Y is a proper subset because the number of elements in Y is not equal to the number of elements in X. That is all. Because the number of elements in Y is not equal to the number of elements in X, we can say that set Y is a proper subset. I guess we are following. Now let's take another set, set W or set Z. Let's call it set Z. And then set Z contains the elements. You want to check whether set Z is a proper subset or improper subset. But first of all, you agree with me that Z is a subset of X because all the elements in set Z can be found in set X. So set Z is a subset of set X, or set X is a subset of set Z because all the elements in set Z can be found in X, all the elements in set X can be found in set Z. So they are subsets of each other. We want to determine if set Z is a proper or improper subset, right? Good. Now, with improper subset, we said that the number of elements in the subset must be equal to the number of elements in the superset. So we know that the number of elements in Z, we have how many elements? 1, 2, 3, 4. So we have 4 elements. And then the number of elements in set S, we have what? 4 elements. So you agree with me that the number of elements in Z is equal to the number of elements in what? X, which is what? 4. So we can say that set Z is an improper subset of X. That is all. So that is that for improper subsets. So we are looking at representation of subsets on the Venn diagram. So we said that from our previous definition, we said that a set M is said to be a subset of set N if all the elements in set M can be found in set N. So we give an example that, let's say set M contains the elements 1, 2, 3, 4, 5, 6, and then what? 7. And then we said that, sorry, and then we said that set N is equal to 1, 2. So we said that set M is a subset of set N. And we can represent this using the Venn diagram. Good. So we are saying that set M is a subset of set N. It means that set M is contained in what? Set N. Good. So if we are to draw the Venn diagram, we are saying that set M is contained in what? Set N. So it means that set N becomes what? The bigger set. And then set M becomes what? The smaller set. So we can represent it using the Venn diagram. So this is set M. So the shaded portion is what? Set M. Because we are saying that set M is contained in set N, meaning it is a subset of what? Set N. And then the bigger circle becomes what? Our superset, which is what? Set N. So we can represent it using the Venn diagram.